Okay guys, welcome back to another video. Today we will be tackling circular measure. And yeah, I found these questions from like the additional math textbook itself because I couldn't really find some challenging ones online, nor could I find it from like past paper questions, because usually past papers I realized that they don't really touch too much on circular measure, and even if they do, they're pretty basic, they're pretty simple. So yeah, I found that the books one actually reflects a bit of a challenge more than other sources, which is good, right? And yeah, as always, I suggest you guys to try out the questions first before looking at the solution, and that way the solution sticks more to your head. Alright, without further ado, let's get started with number one. Alright, by the way, this one is a different question, and this one as well. Okay, for number one, a hollow cone has a base radius 10 centimeter and a height of 24 centimeter. The cone is unrolled to form a sector of a circle, and what are the angle and area of this sector, right? In terms of like length of solution, this one is not really long. In fact, it's actually not that hard, but I like the idea of like combining more than one topic together, because it really tests your understanding, right? And usually, I find a lot of students do this, like, because they know that, let's just say, I'm really bad at drawing, so I apologize. But yeah. So let's say we have like a cone, and it's circular, right? Right. And they know that the radius is like 10, and then they got the height. So what they do is like, they get this, right? This one is obviously a right angle, and this one is obviously theta, right? And they will have like the radius is 10 here and the height is 24. So they think that the angle would be like tangent theta is equals to 10 by 24, right? But this is not the way to go. This is not the way to go, as it does not reflect the entire sector, right? Because if you think about it, a cone is like 360, right? It's 360 degrees at the top. It's like a 3D figure. But if you only look at it from this perspective, it means you're looking at it from like a very basic two-dimensional thing, if you get what I mean, right? Because this only looks at one plane of the cone and not the entire plane, right? And so what we should do from here is, the keyword is the cone is unrolled. So if you think about it, we have an area of a sector, and then if you roll it back up, it becomes a cone. Essentially, the area of the sector would be equal to the surface area of the cone. Right? Get what I'm speaking right now? Right? And this is where we apply a bit of logic as well. Let's just say that they do not tell us that the cone is hollow. That means the surface area will be equals to pi RL plus pi R square, right? Let's just disregard the fact that it was hollow in the first place, right? But if we still apply our logic, even if they do not tell us that it's hollow, even if they do not tell us that it's hollow, we will know that the surface area we take in this calculation will only be pi RL, because that's the one that is actually affecting the area of the sector, right? So right here, if we have pi RL is equals to 1 over 2 r square theta, right? So pi RL is essentially pi times 10 times L is this thing, right? Times the square of 10 square plus 24 square, and that will be equal to 1 over 2 r square theta. So area of the sector will be, let me just quickly count that, times 10 times pi. Well, the sector will be 260 pi. You can simplify that further, and theta will be equal to divided by, yep, and theta will be equal to 2.42. And yeah, if you realize, you might be wondering as to where did I get the 2.42 from. Let's just say right now we have 260 pi is equals to 1 over 2 r squared theta. The big question right now is, what's the r, right? Because we're trying to find for the theta, that means we need to know the r. Here you might think the r is still 10, but try to think about it, right? At first we have this cone, and then it turns out we have this sector, right? And with theta right here, right? I think it is understandable if I say that the r of the sector right here is actually the L itself. Because if you imagine, if you fold it back into a cone, the L is actually the R of the sector. And therefore, the R here is equals to 26. And yeah, with that, we have solved question number 1. All right, let's move on to question number 2. All right, let's move on with question number 2. Right, okay, we have this question right here. The diagram shows 3 points. The line is the length of the arc ACB. All right, ACB is simply where we know S equals to R theta, and therefore S is equals to 10 times. Remember that we need to convert it first to radian, 60 divided by 360 times 2 pi, and that will be equal to 60 divided by 360 times 2 pi. That will be equal to 10.5. Alright, that's for part A. For part B, area, okay, that's simply 1 over 2 r squared theta, and that will be also equal to, remember that, again, the theta must be in radian, so we have 60 divided by 360 times 2 pi times 10 squared times 1 over 2, and 52.4. Notice that I'm following it, like they want it to 1 decimal places. Normally, money is to 2 dp, angle is to 1 dp, and if it's not stated in the question, it's usually always to 3 significant figures. But mind you, when doing or working, right, a lot of students forget this, but like for example, if they do some calculation, let's just say 1 over 2 r squared theta here, right, at here, actually this is actually not allowed. It's just because this is not an exam, that's why I do this. You actually must write it to a more accurate value first. Like you write it like, let's say 52.3598, then you put like dot here, and then you will put like the estimate sign, and then you put it to 52.4. This is the best way to do it. Although like the IGCSE, the syllables or like the mark scheme did not really specify the need for this type of technique, it's always the safest. And it gives a good impression to your examiner, and it shows that you know what you're doing, right? Because it makes no sense that 1 over 2 r squared theta is equals to 52.4. That's the estimation, not the value that you will get from the calculation itself. All right, with that being said, let's move on to part C. All right, they want us to find the area of the shaded region ACBD. So let's just draw it out first, so it's easier to understand. So we have this, and we have this. Then we have this, and then this. Alright. That's supposed, oh nah. It's gonna be confusing. Alright, and then the shaded one is this, right? Okay. Now I can say that, okay, let us see here. I think the thing to go for here would first to be calculate for AB, right? Okay, so AB will be equal to, just using the cosine rule, so we have 10 squared plus 10 squared minus 2 times 10 times 10 times cos 60, and that will be equal to 10 squared plus 10 squared minus 2 times 10 times 10 times cos 60. That will be equal to 10 itself. Alright, that was dumb. I just forgot, this is actually an equilateral triangle. If you see here, this one is 60 as well. This one is 60 as well, so definitely all sides will be equal to 10. My bad. And yeah, per that logic, you know that if a tangent touches the circumference of the circle, it will form like a 90 degree. So since this one is 60, then I can say this part here will be 30, right? Alright, with that being said, we can find the area of ABD. Take note, ABD includes this thing right here. So ABD will be equal to AB times AD times sine 60 divided by 2, right? And AB is equals to 10, and AD is equals to 10.5, because we have the information that AD is equals to the length of the RACB, and we have times sine, my bad, it's not sine 60 but sine 30 times sine 30 divided by 2. Alright, let me just quickly find that out. 10 times 10.5 times sine 30 divided by 2, and that's equals to 26.25. Alright, so right now the thing we should do would be actually to subtract that thing here. It's the area of the segment ACB. Oh, Wait, I just realized something. Oh, okay. My bad here. Correction for B. In B, what I got was the area of the entire sector, which is 52.4, right? But I didn't subtract it with the triangle, right? I hope you guys noticed that. If you guys noticed that, that's brilliant, right? I'm gonna not change that anymore because it will disrupt the entire working. But yeah, I'll just show you, like, it's pretty simple actually. So since we know that 1 over 2 r squared theta is 52.4, so 52.4, we just need to subtract it with the triangle OAB, and that will be equal to 10 times 10 times sine 60 divided by 2, right? And that will be equal to 9.1, and hence the area of the shaded region will be equal to that, to the entire area, which is 26.25, which is ABD, minus the small segment ACB, and therefore we have 26.25 minus 9.1. That will give us 17.2. Alright, cool. Let's move on to the last part of the question, which is part D. Alright, so for part D, oh oops, I used the black one. For part D, we want to find the length of BD. Okay, I think this is pretty simple, right? Since we have this, and this one is BD. That's not the actual shape, I apologize. But yeah, this one is 30. We have this 10, we have 10.47, so BD is just the cosine rule. I think that's pretty simple. So 10 squared plus 10 squared plus 10.47 squared minus 2 times 10 times 10.47 times cos 30 square root of answer. That will give us 5.3. Okay, that's part D done. Okay, let's move on to question number 3. Alright, for question number 3, OAB is a right angled triangle with OA equals to 6 and OB equals to 8. An arc AC is drawn with the center at O. Calculate the angle AOC in radians and the area of the shaded segment. Let me just try this out. Oh, you can't actually do that when recording. I was about to take a screenshot, but you can't actually do that during a recording. But oh well. Yeah. So the angle AOC, what they're trying to find, what they're trying to call us to find is this thing. It's this thing right here, this angle. This one right here. And since we know that this is part of a circle, then we also know that this is equals to 6 as well. Right, pretty basic stuff. Alright, okay. So the first thing we can do is actually find this angle right here. Right, so OA tangent theta will be equals to 6 over 8. Therefore, theta is equals to 36.9 degrees. And with that being said, we can actually find this angle right here. Let's just name that x. And x will be equals to 180 minus 36.9 minus 90, and that will give us 180. That will give us 53.1. Okay, this is where a bit of understanding comes in as well. Notice that since these both sides are actually equal, right, this actually OAC is something we call an isosceles triangle, right? Pretty sure we all learned this already back when we were doing primary math, right? So since the radius is 6 and 6, we also have learned that the angle opposite to the length, which are equal, are also equal. I hope that makes sense. Let me just draw it out. So we have this right here, here. So we have 6 and 6. Therefore, this angle and this angle right here are actually equal, right? Since we know that this right here, which is equal to that part, is 53.1, so we know that the angle AOC is equal to 180 minus 53.1 times 2, right? And that is equal to, wait a second, 73.8, right? But notice that they want it in radians, so let's just really convert it real quick. So divide by 360 times 2 pi, right? And that is equal to 1. 29. Alright, job well done. Okay, let's move on to the next part of the question. This one is similar to the previous question. So the area of the shaded segment will obviously be equal to 1/2 r squared theta minus 1/2 6 square sine theta, right? And make sure that it's all in radian right now since we're calculating it with the 1/2 r squared theta way. I think it's pretty basic stuff. I'll just sub in the values. So we have 1/2 6 square times 1.29 minus 1/2 6 square times sine 5 point, sine 1.29. That will give us, let me see, 1 times 6 square times 9 minus 1/2 times 6 square times sine 1.29. And that will give us 5.92. Alright, and obviously in centimeters square. Okay, let's now move on to the last part of this topic right here. Alright, moving on to the last question, question number 4. This one I actually find kind of tricky. I'm not sure if I don't see if I'm the one that's not seeing an easier solution for this. But yeah, this one requires quite a bit of logic. Okay, so let's get started. Calculate the length of the perimeter of the shaded region, the area of the shaded region. Okay, so first of all, we can just do this actually, right? We can find the arc, right? The arc will be equals to r theta, and that will be 10 times 0.8, and that will be 8, right? And we can find the length of AB. That will be the cosine rule, using the cosine rule. So that will be 10 squared plus 10 squared minus 2 times 10 times 10 times cos 0.8. Right. Remember that since we're using a radian here, remember to put your mode to radian. So let's just see 10 squared plus 10 squared minus 2 times 10 times 10 times cos 0.8 squared. Alright, so that will give us 7.79. Okay, so let me just bring it back to the previous question we did, because there's a connection. Right, remember the part where I said that this is an isosceles triangle, right? Since this one is 0.8, this one will actually be, in a triangle there's 180 degrees, so that's pi, right? So right here we have pi minus 0.8 divided by 2, and that will give us 1.17. Alright, with that being said, it means we can find the other angle here, because remember, since it says that this is a tangent, just like the question right here, that means the entire angle is pi/2 or 90 degree. So we can say that this angle right here will be equals to pi/2 minus 1.17, and that is equal to 0.4, right? This is where it gets kind of challenging, right? So right now we have this triangle right here. This triangle right here. Right, this one we know the length is 7.79, and this one we know it's 0.4, right? That means we actually can know the length of the hypotenuse, but first we actually need to divide it into 2, right? So right now we have cos of 0.4 will be equal to 7.79 times 0.5 over hypotenuse. And the hypotenuse will actually be equal to AP here, right? Okay, I hope you guys can follow with that. So let's just put it into the value, and so 7.79 times 0.5 and divided by cos 0.4, and that would give us 4.23, right? And yeah, we just need to multiply that with 2 because we have the section with PB as well. And since they want us to calculate the perimeter, notice it's the arc and not AB itself, and therefore we need to add it with 8, and that will give us 16.5. And yep, that is part A. Sorry for not writing units if I forgot. I do apologize. But please, please, please do not forget to write units in your exam, especially like I think in IGCSE they penalize you like once or twice. Like, that kind of hurts already. But yeah, once you get to like IB or A levels, like if you do not write units, I think they just completely disregard your answer. But I'm not sure. I think IGCSE may have tightened their rules as well, right? Because I think no units like does not like make your answer make sense. Okay, so let's see. For part B, the area of the shaded region. Okay, I think this is pretty basic, right? So this type of question, like the area of the shaded region, like the small thing right there, it's always asked. I just realized it's like always asked, even in past papers. So yeah, it's simply 1/2 r squared theta minus 1/2 AB sine theta. I believe we already have found all the values. So all we have to do right here will be to just sub them in. And that will be equal to, let me see. Um, 4.13. Alright, so right now we have the area of the segment, but pay attention here, right? What they want is the shaded region, and if you realize the segment is actually this thing right here, right? So that's like only half of the problem right there. So right now what we need to do is actually to find the area of the triangle APB, right? Triangle APB, and that will simply be equal to, since we know it's like the hypotenuse and like the base, so we can have like 7.79 times 0.5 times hypotenuse is 4.23. That will give us 16.5. And yeah, wait, I think I completely butchered the whole thing. Oh wait, oh my god, I'm being an idiot right here. Notice that I actually times the base by the hypotenuse, and yeah, I completely forgot to times sine 0.4, because you only don't need to use like the sine 0.4 if you're actually multiplying with the height, and yep, that will give us 6.4. Okay, so if you notice right here, I actually didn't divide the whole thing by 2, because if you realize we're trying to find the left hand side of the triangle, and then we multiply that by 2, and if you realize if we just divide it by 2, then we multiply it by 2 again, it will basically give us the same answer, right? So that's why I didn't divide it by 2. And remember that I times 7.79 times 0.5, that's because 7.79 is the entire base length. Right, we need to divide that by 2, that's why I times it by 0.5. Okay, enough of that blabbering. Alright, so 6.4, we need to minus that with 4.13, and that will give us 2.29 centimeters square. Wait, no, meters square. Yep, that is it for circular measure. I hope you guys enjoyed the session, and yeah, if you have any other questions or like other topics you want me to cover, feel free to put them down in the comments down below. Right, all the sources will be referenced in the description down below as well. And yeah, I'm developing like this really cool website on like IGCSE, like about IGCSE, like stuff you have to know actually, I think, about IGCSE to get that A star, like a guaranteed A star. Especially it is dedicated for math and science, yeah. So yeah, if you are taking math and sciences, math and the sciences, I hope you guys can check it out. Gives you basically like notes, tips, how to like hack the syllables, how to like quote unquote hack the mark scheme and like the examiner reports, so that you know like things that students always misunderstand, things that students always forget, and such stuff, right? Okay, without further ado, I'll see you guys on the next one. Bye.